Hello everyone, my name is Orisa Ivan. I'll be talking about the concept of feature engineering as one of the concepts that's needed in feature in creating a model, predictive model in machine learning. First, we are going to start with the definition of what is feature engineering. We just hear about the term feature engineering. What does it mean? Feature engineering is the process of selecting, manipulating, and transforming raw data into features that can be used in supervised learning. As you know, data just consists of random features. Data is not organized. Data can be organized, but data has it's very hard for a model to understand data when you enter it as numerical values into the model. So we need to extract a few features from the data. We need to divide data in, breaking it down into simpler forms, simpler features that is easier for the model to understand. So when we talk about a feature, what is a feature? A feature is like a characteristic. So a feature is any measurable input that can be used in a predictive model. So an examples of features: the color of the object, the age of people, the color of people, the color of the people, they are blacks, they are the whites, the sound of someone's voice. All those are features in data. So if we manage to extract this from a big portion of data, it is very easy for the model to understand these features, to break them into if you break them down, break the data into uh, more understandable features. So we have a feature engineering basically consists of some processes, some 5 processes, that is feature creation, transformation, extraction, explanatory data analysis, and benchmarking. So I'll be talking about feature creations and then feature transformation. Then my other colleague will talk about extraction. So when we talk about feature engineering, this is an illustration demonstrating how feature engineering is comes about. So we get the raw data, we convert the raw data into features, and then these features are used to train a model that makes the model easier to understand these features than the raw data that is disorganized. So let's look at this example. So this is a data set I obtained from Mendeley. This was recorded for 5 home appliances. That is a TV, air conditioner, a fan, a computer, and a lamp. So their total power consumption was recorded, and there is as noted down after every minute. As you can see from this data, so this data is disorganized, so we have to first start organizing this data. When you look at this corridor for timestamp, timestamp has a lot of features, has the date, has the month, has the year, and has the time. But now it will be very hard for the model to understand which one is the date, which one is the time, and uh, which one is the month. So that's why we need to extract these features from this data in order to be able to. Uh, if we extract these features from data, it will be easier to compute, and it will be easier for the model to understand. It will be easier to train the model on this data, and the model will easily understand these features other than giving it this timestamp data as it is. So let's start working on the timestamp. First, we had to break down the timestamp into the hour, the day, the month, weekday. So as you can see, the hour was 17. That's on a 24-hour clock, and it was so it's 5 on 12 o'clock. We have the day, it was 29. Then the weekday was a Friday. Then month was December, that is the 12th month of the year. So after working on the timestamp, now we calculate some of these agreed the maximum mean, the peak power consumed, and then the minimum mean. Now, as you can see here, we use these formulas. So to calculate the mean power, we had to uh, we have to add the power consumption at a particular time for all the appliances. Then we divide by the number of these appliances, that is 5. Then the maximum power, we get the maximum power consumed at a specific time by the appliance that consumes the highest amount of power at a specific time. Then the minimum power, we get the minimum amount of power consumed by that appliance at the time. So now this is the data we transform. This is the data now, more of organized. So we worked on the timestamp. Now we have the hour, we have the day, then we have the month, then we have the weekday. So calculating the minimum power, the mean power of the max power, then we have the minimum power. As you can see, that's the transform data. So that data now it makes it easier for the model to understand. So now we do some visualization of this data to make it more easier for the model to interpret it. As you can see, this is a graph of the distribution of mean power. As you can see, it is mean power in kilowatts against the frequency used at a particular time. So you can see the trend of how this was, how the power was used. And then now, as you can see, it shows the average power consumption is spread across the different values. And then now let's look at the feature engineering processes. So let's look at, it has various processes, but we shall look at a few of these processes. So one of them is feature creation. We shall look at the concept of feature creation, then feature transformation. Then I will leave my colleague to look at the feature extraction. So when we talk about feature creation, what does feature creation mean? So when we talk about creating something means building something, innovating something. So creating features involves creating new variables, which will be most helpful for our model. So we create new variables from the data that we have. So these new variables that are created can be used in the data. So this can be done by adding or removing some features from the data. As you saw from the previous example, the timestamp column, we had to create new features from the timestamp column, that is the hour, the day, the date of the week, the weekday. So we had to create more features from the data. That is basically we performed an activity known as a process known as feature creation. So what are some of the types of feature creation? So when we talk about feature creation, it's domain specific. So when they talk about domain specific, this one is specific based on some rules. It follows some domain used by a domain or a standard set by someone who is working on the data. Then when we look at the data driven, we create new features, then observing the patterns in data. And you can see from the previous data, we had to create new features. We use data driven because we had to create new features, observing the patterns in the data. Then look at the synthetic, generate the new features by combining the existing features or synthesizing new data points. So we had to generate the new features by combining the existing features, that is synthetic. So these are some of the types of feature creation that carry out with data. And then we have some of the importance of feature creation. It improves the model's performance. Now this one comes in as a result of as you can see, feature creation, creating more features makes the model easier to understand and increases the accuracy of the model when making predictions. Because the data that the model will be trained on will be easier. It makes the model also bring out a simpler output. Increases the model's robustness. So this increasing the model's robustness mostly since that they will train the data on simpler features, and this will increase the model's performance to anomalies and those misbehaviors of data. Uh, Misbehaviors in data, that's basically increasing the model's robustness. Then we have improving the model's interpretability. So since the data you train, you will create more features, new and simpler features. So this one, the data that will be used to train the model will be more simpler, and the model will be able to understand this data and interpret it, and also give out a more simpler output or a more simpler prediction that is easier for the user also to understand. And then increases the model's flexibility, since now we train this model on different features of data. So this model can be used in most cases. The model can now be flexible, used to carry out various operations. And then now let's look at the concept of feature transformation as the second process. When we talk about feature transformation, we talk about transforming something, that's like changing the basic appearance. So transforming features into more suitable representations, like as we saw some time back, we had to transform the mean data into a graph, visualizing the data, making it more easier for the model to read, because since the model will also follow the trend of the data that has been visualized. So we have a simple picture here of uh, transforming the data. We had a vehicle, then we had to extract parts of the vehicle one at a time. So as you can see, this one makes it easier for the model to understand, since the model goes part by part. So this one makes the model understand more about the data it's trained on. Let's look at the types of feature transformation. We have normalization, so rescale the features to have a similar range. So, you know, the features of data, especially statistical features, don't follow a pattern. Some may be over the range. So this normalization, basically, we rescale the data. We have to put them in a similar range so that some features don't dominate others. If the range is from 0 to 1, we have to make sure everything we are working on has to be in the range of 0 to 1. We have to convert all the values to lie within the range. Then we have scaling, data scaling, that is used to transform numerical values to have a common scale, have a similar scale so that they can be compared more easily. So scaling, numerical variables also do not have a similar scale. Numerical variables have different scales. As you can see, even from the data we had, the data has a different scale. Some numbers are big, so we have to transform these numerical variables to have a similar scale so that it becomes easier for us to compare this data, to compare the trend of the data in terms of behavior and performance and all that. Then we have encoding, we have transforming the categorical features into numerical representations. Uh, this one also, it's straightforward. We transform the categorical features into numerical representation. That is, some features are already categorized, they already lie in a specific category. So we pull out these categories and then we transform them into numerical representations. So some of the examples of encoding are hot encoding and then label encoding. Then we have transformation itself. The transforming features using mathematical operations, like to change the distribution or the scale of the features. As you saw, we had to use the mean, we had to use the maximum power, we had to use the minimum power to get data. So we transform some of the features of the data using those mathematical operations. Let's look at some of the few advantages of feature transformation. So it also feature transformation improves the model's performance, since now the data that has been transformed, it becomes easier for the model to understand this data. Increases the model's robustness. Also, this one model is trained on simpler data, so this one makes the model more robust and prevents it from anomalies. We have improves computational efficiency. So this the data trained on the model. Yeah, we shall have simpler features trained on the model, and when we use simpler features, we don't have to use more resources. It reduces the computational cost and increases the efficiency. So then improves the model interpretability also, because the data is simple. Train a model on simple data, the output, the prediction of the model will also be simpler for the user to understand. Let's look at the importance of feature engineering. So when you look at this, improves user experience. As you can see, feature engineering, as I said, the concept of feature engineering, as I've been saying now, you'll be there, uh, you'll be able to analyze a set of data that is getting more experience. You'll be able to analyze a data set, and then you can be able to extract useful features from the data set. And then this improves your experience, because if the user gets used to analyzing data and converting all values of data, uh, extracting useful features from data, this improves your experience towards understanding the trend of the data. We have a competitive advantage. Also, this one improves the competitive advantage, as you saw earlier. So to meet the customer needs, so as you can see, we extract features, simpler features from data. This one makes the customer needs the data that can be used to train his model. So after you carrying feature engineering on the data, it becomes easier for the customer to just come and pick the data that has simpler features for the customer to understand. As we saw how we converted the timestamp, it would be very easy for customer to understand the timestamp now more than how it was looking at first. Then increase revenue also. This carrying these computations and data, you'll be the feature engineer will be given something so that earns revenue to you as well. Then feature proofing also, yeah, that one opens up your careers and gives you more advantage. So we have feature engineering techniques for machine learning. Some of the feature engineering techniques are one-hot encoding, technique used to transform categorical variables into numerical values that can be used by machine learning models. We have binding technique used to transform continuous variables into. We have continuous variables can be numbers from 1 to infinity. So as you can see, we need to transform these continuous variables into categorical variables. We have to scale them into as an understandable category that can be used, that can be easily understood. We have feature split involves dividing single features into multi. So after us dividing these simple features, we can furthermore divide them into sub features, smaller features. That is, it becomes easier for the model to understand and improves its performance. So that is all that I had. Thank you. I will leave my colleague to take on from there.
Hello, my name is Emmanuel Gracious, and today I'll be taking you through feature extraction and ADA ADA Module 21. To begin with, feature extraction is the process of transforming raw data into meaningful features that improve the performance of machine learning modules. As machine learning, we have supervised learning and unsupervised. So it's all about feeding in the data. So transform raw data into meaningful features for the machine learning model. That is all feature extraction. It helps reduce dimensionality, remove noise, and highlight the most relevant information from the data. The purpose we have improved model accuracy, that is extracting relevant features enhances the predictive power of machine learning modules. If we take an example like in image classification, we have extracting edge features helps the model detect shapes better. And another one, we have reduce complexity or reduce dimensionality. This one leads to faster computation and reduces storage needs. Example, when using take an example of using the principal component analysis or a PCA to transform high dimensional image into low dimensional space. And another one, we have enhancing interpretability or extracted features make data more understandable and explainable. That is, if you take it, example in a customer analytics, we have transforming raw purchase history into average spending in a month, or it's easier to interpret. Then we have another handle different data types or converts unstructured data types data into structured numerical representations. Example is converting images into feature vectors. And lastly, for the purpose, we have efficient computation, that is selecting only important features, speeds up training and interference. Types of features or types of features or in feature extraction, we have numerical, categorical, text and image. We shall look these ones further. So when we see the feature extraction pipeline, this generally transforms raw data into useful features for machine learning modules. The pipeline consists of several key stages. And if I talk about four, we have the raw data control collection. Data can come from various sources, e.g., CSVs files, sensors, and logs. We have data cleaning. Cleaning ensures data quality by handling missing values and removing outliers. We shall see this one also in the ADA code, handling missing values. We have feature engineering, which creates meaningful new features from raw data. We have feature selection, reducing dimensionality by keeping the most important features. Uh, Types of features, memory, we saw the map. Now we are beginning with numerical data. This numerical data is a process of deriving meaningful numerical values from raw data to enhance machine learning modules performance. So just have to derive the meaningful numerical data from raw data. Basically transforms it into numerical data. So this includes basic statistical features that include mean, median, variance, skewness, gap transformation, for log square root standardization. Then we have Fourier transform, extracts frequency-based features. And the example of a Python code is there. This is the ADA codes that are included. We shall see importing the library for the NumPy as a name. Then we have an example of the final log feature. This one is the transformation stuff. So as an example, then on the next of categorical data, this one transforms categorical variables into numerical format suitable for machine learning. Yeah, from raw data, transform categorical variables into numerical format. This one, and we have the improved one. We have one hot encoding converts categorical into binary columns. We have label encoding assigns numerical values to categories. We have target encoding, which is target meaning for categorical values, binary encoding. Python example from display processing. We imported this library for one hot encoder, as you can see. Then for text data as a feature extraction type, we have it converts raw data into numerical features that machine learning modules can understand. This is crucial for natural language processing tasks such as sentiment analysis, topic modeling, and classification. For there, it's a tidy subsection. You have bag of words. This one represents text as word frequency vectors. Then we have TF-IDF, term frequency, inverse Gaussian frequency, where is words based on contents. Then we have word embeddings for deep semantic understanding. Python code is there. The feature, the library imported is a tip for TF-ID, as you can see. Then for lastly, for the image data as a feature, this one it involves converting images into numerical features that can be used in machine learning and deep learning modules. It helps identify patterns, textures, and structures in images. You have the textile intensity features, graphics features, histogram, oriented gradients, capture edge directions, deep features, users determine values. So Python example code is there, the ADA code. Yeah, the library imported is for Vogue. So ADA, a short overview of the exploratory data analysis, the codes used there back. This one is the essential step in data analysis that helps in us understand the structure, patterns, and relationships within a data set before applying machine learning algorithms. So the goal is to summarize the main characteristics of the data set and visualize it to gain insights and inform further analysis. So why do we use the ADA, or why do you analyze data? Because it's all about understanding the data set. So we detect the missing values, identify patterns and correlation, then understand data distribution. That's mainly the over part. So we wrote code, and this is a summary, statistics and machine values, Python code. So here we see this code is for summary statistics, and this code is for checking the missing values. When you run it, it will bring you the list showing you the missing values. So data visualization, as we have talked here, Uh, Here we have histogram, boxgrams, scatter plots or pirates, correlation app, fit apps, Python code. This one we import this library, then the correlation heat map. This code is run. Now I didn't take time to run the code to show you how it works. Time. We have feature collection techniques. We have filter methods, validation, ramper methods, we have embedded methods, some examples. Then there are Python code. You have from you import these libraries. When you go further to read this, the imported libraries, you know what I'm talking about. These are the libraries we fetched to help us run this code. As you see, we are running the setting module as logistic regression. Yeah, the library imported will help us run. In the conclusion part, the whole summary of the feature extraction and the EDA combined. Feature extraction improves model performance as we have seen. It's generally transforming raw data into numerical data to be used in the machine learning. ADA helps us understand data structure. So the data sets we are given helps us to analyze and understand from missing values and update all that. So when you use a mixture of Dominion, knowledge, and automation, so we are next steps is applying this feature extraction to real world assets. Thank you very much for having me.